Good morning, class. Today we're working on lesson 54, which is rate word problems. But first we're going to go back and look at and review a little bit, just so we make sure that we know what we're doing before we start these word problems. So in the last lesson, we solved ratio word problems using proportions. We can solve rate word problems in the same way. But first, what are rates? So a rate is the ratio of two measures, okay? So we always in ratios, we have two for different numbers. We're comparing two things, right? So you could have 5 cats to 7 dogs. Or you could have a ratio of boys to girls. So it could be like 16 to 14, I think was one of the examples we were working with. So those kind of had the same unit, and they weren't necessarily measures, but rates are specifically dealing with measures. So they have a unit of some sort of distance, measure, time, those sort of things. So 65 miles per hour, though you only see one number, there's actually two, okay? Because you're going 65 miles in 1 hour. So the rate is like 65 to 1. So you'll go 65 miles per every 1 hour that you travel. 25 miles per gallon, you're going to go 25 miles for every gallon of gas that you have. That's like a mileage rate. Or $12 per hour. For every 1 hour that you work, you will earn $12. Miles is a distance. Gallon is like a liquid amount. Miles, again, is a distance. An hour is a measure of time. You can do dollars, which is like monetary, per hour, which is time. So you're just comparing, or you're looking at two different measures and you're putting them into a ratio. Okay, so that's what a rate is. So let's break that down. Yeah, so a rate can be the rate of speed is distance over time. So that would be the rate of speed is distance. So we're going, let's say, 65 miles, right? This is our distance over 1 hour. So really, when you say 65 miles per hour, this like bar line here, this slash over here that are both kind of doing the same thing. When you're reading different rates, you usually say something per hour or something per day or per gallon, etc. So this bar, it's 65 miles per hour. So I kind of just like broke those down into some more words. You can read them. Oh, good. I'm still drawing. Pointer, clicker. Here we go. Okay, so let's try a problem that's just using rates. It's kind of a word problem, but it's not as in-depth. So on the 390-mile trip, Arnold's car used 15 gallons of gas. His car averaged how many miles per gallon on the trip? Okay, so what do we know? We know how many miles he traveled. We know how many gallons of gas he used. Okay, and it's asking us how many miles per gallon for the trip. So even just like breaking down the language, we need miles per gallon. So I'm going to put my miles, like you can see here, I put them before our divisor, and then we have 15 gallons. You could also I just was typing and I can't do the bar line, but you can do a bar line like this and then put 15 gallons. Look at that cursive. Wow. Okay, so what we want to do with rates is to get them to their like smallest amount. So you usually want it per like 1 gallon or per 1 hour. So that's a really important thing of we need to reduce very frequently when we are doing rates. It's like we kind of got away with not really doing it when we were working with ratios. I appreciated those of you that did do it anyway. But when we're working with rates, it's very important to reduce when possible and like when it's necessary. So some of the word problems today, you're going to be like finding the bigger number. Like they'd tell you how many miles per gallon Arnold would travel, and then they'd say how many miles would he go if he used 15 gallons of gas. There's some like reversing. But okay, yes, here, let's continue. So if you reduce that down, you get 26 miles for every one gallon. So I pray that's making sense. If not, we need to do some work before you move on to the rest of this. So actually, I want you to go and try on your assignment. It's all on the same Word doc, but I need you to pause the video, go to a different tab, open up Google Classroom or whatever you are on, do the like 3. I think I didn't give you all of them, but do the practice set for lesson 46. Okay, now we're going to move on to rate word problems. I hope you did the practice set. If you didn't, you should go do that. Anyway, okay, because these are only going to get more complicated, and if you don't understand the basics, then we need to talk about that and get that figured out before you move on to these, because these will just be hard if you don't know what you're doing. Okay, if Mr. Gomez drives his car at an average speed of, that's supposed to say of. Good thing I can edit this while I'm teaching. 55 miles per hour. How far will he drive in 3 hours? So I think, okay, you don't have to use them. Actually, I set them up for you on your worksheet for at least 2 of the problems. Putting them into a table will help you visualize and understand more of what you're doing versus just putting your rate into a proportion and multiplying and stuff like that. This will help you keep organized and understand what each of the numbers mean. And when you get your answer, you'll be like, oh, I know what my units are and I know what I'm talking about. So please use the table. It will help you. I promise. Okay. So I set up our table right here. So the rate, he is traveling at 55 miles per hour. So our rate is 55 miles. I put the units over here. He's traveling a distance. He's traveling in miles. In 1 hour, he can go 55 miles every hour. Okay. Now we need to figure out how far will he drive in 3 hours. How do you think you will figure that out? Pause the video, try to figure it out. Okay, let's take a look. So what we can do is we can set up a proportion. I honestly feel like this problem you might be able to just do in your head, and that's okay. But this is how you would do it normally. In case, if you're not sure where to start, you can always set up your proportion. So I took my first column, I took 55 over 1, and I set it equal to this column over here, which is our actual measure. And we don't know what this is, so I used the variable d for like distance. And I put d over 3. So I have our 55 over 1 is equal to d over 3. So now they're equal, they're set up, you can cross multiply. Okay, so when we cross multiply, our new equation is, drumroll please, 1d is equal to 55 times 3. Do the math. What does that equal? What does D equal? D is equal to 165. Actually, let me just double check that. That's what the book said, and I trust the book, but I should also do the math. Boom, it's right. Cool. Okay, so we have an answer of 165. Let's put that in here. $165. Okay, and I'm actually going to copy this and put it on the next slide. Okay, if Mr. Gomez, so this is our question. If Mr. Gomez drives his car at an average speed of 55 miles per hour, how far will he drive in 3 hours? Okay, so we got the answer of 165, but what does that actually mean? What does that actually mean? Okay, so if I go to my chart, let's take a gander. Okay, so I know 165 is in my distance row and my actual measure column. So I think that means that Mr. Gomez, if he drove 3 hours, would actually go 165 miles. Okay? Do you see that? Does that make sense? I pray it does. So he's going to travel 165 miles in 3 hours. Okay, let's try another one. How are we doing on time? Excellent. Okay, if Mrs. K drives an average of 24 miles per gallon, then how many gallons of gas will she use on her trip of 300 miles? I set the table up for you. We have our rate of 24 miles for every gallon. Okay, I put my units over here. You can also put, like, if you want to put distance, you can put distance and then have it be in miles, and then you can use like fuel and then have that be gallons. Okay, but 24 miles for every 1 gallon of gas. So it's telling us that she actually is going to go 300 miles. So we need to figure out how many gallons of gas she's going to use. So we need to set up our proportion. So we're putting 24 over 1 is equal to 300 over G. Okay? That is our proportion. We're just setting the two columns equal to each other. Whoops. Okay? So now we will cross multiply. Okay? It might be helpful to do this on paper or on a whiteboard that you can erase. So we're going to cross multiply. So we're going to have 24G is equal to 300 times 1, which I just simplified to 300, okay? So now you have to divide both sides by 24. 24. Divide this side by 24. That was real smooth. So what do we get? Oh, I'm still drawing. Got it. Okay, so we have 12.5. So G is equal to, let's just fill this in, 12.5. Okay, do I have another slide? Okay, so what does this mean? What does this mean? So if I was trying to answer this question, let's make my text, I'm going to do blue. That's going to be my answer. Mrs. K needs 12.5 gallons of gas. Okay, it can be as simple as that. If you want to be very precise, which I would recommend, she needs 12.5 gallons of gas to go 300 miles. Okay, this is being very thorough. That is excellent. Strive for excellence. Let's go. Okay, one more problem. I'm going to try to do it quick because I want you guys to have plenty of time to do your work. Okay, Hannah works at a sporting goods store for 8 hours and earns a total of $68. What is her hourly pay? And then use the hourly rate to find out what she would make in 30 hours. So, what do we do first? Okay, let's do per day because that will help us. Okay, so she worked for 8 hours. She earns $68 total. We need to figure out how much money she's making for 1 hour of work. Okay, that's her hourly pay. Okay, so let's set up our table. I have dollars, I have hours. Okay, we don't know what her rate of pay is, so we don't know how many dollars she makes in 1 hour, but we do know that she makes $68 for working 8 hours. Okay, so now we need to set up first let's set up our equation. We're saying, let's say D stands for dollars, D over 1 is equal to, because we're just setting the first column right here is equal to this column, is equal to $68 over 8 hours, okay? Now we're going to cross multiply, okay? So we have 8D is equal to 68, okay? So now we have to divide both sides by 8. Also, this would be just simpler if you just divide 68 by 8. Not all problems will work that way, but this one does. Because your 1 and your variable are on the same side. So it's like pretty simple of just like, if you know that you worked for 8 hours and this is how much you made, you can just divide the two numbers. Okay, so 68 divided by 8. Let's do that. Is 8.5. So D equals 8.5. So her rate of pay is she is making, so we're working in dollars. So does 8.5 make that much sense? No, not really, but kind of. But $8.50 makes sense, okay? Because this is like $68. Where's my dollar sign? There we go. Sweet. Okay, so now that we know that this is $8.50, we need to figure out how much she would get paid if she worked 30 hours. Okay, so let's just look at our table here. So it's basically setting this is equal to this. So you can set up your proportion, but basically it's kind of almost already set up for you. Let me just draw that out. It's basically like just putting a line there, putting a line there, and putting an equal sign. Okay, so now we can cross multiply. Let's pick a different color. So I'm going to cross multiply. I'm going to take this times this, which I'll substitute the question mark in for a variable, and take this times this. Let's check it out. Let's try it. Okay, so if I have 850 times 30, that's not right. We have, let's do this right. 850 times 30 is equal to $2. So that is $2.55 is equal to the dollar amount that she would get paid. Okay, so the answer to our question is Hannah would make 200 in 30 hours. Okay, Hannah would make $255 in 8 hours. Okay, so now you can go give the practice set for lesson 54 a try.